Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE and this is my programming series. So over the last few videos we've been looking at classes, and today we're going to continue looking at classes where we'll be looking specifically at operator overloading. So what is this really? So operator overloading is basically the kind of the operators that you already have. Let's say for example the plus sign or the minus sign can be used in classes as well. So whenever we create functionality such that we can use these operators in classes, that's what we call operator overloading. So let's jump right into the code and see how that works. Of course, I'll split the video into C++ and Python as usual, and I'll also put markers on the video so that you're able to skip to exactly where you want. But for the sake of knowing both, understanding the high level and low level languages, I recommend you see both of the videos. Okay, so let's look at C++. So here in C++, we have let's create a class, for example. So let's create a class that will represent a number. Yeah. So let's just say number. Yeah, class number. Have those semicolons, and then now we create our constructor. So our constructor, of course, if you're creating a class that represents number, then we are expecting that we get a number. So you can put a float number. So we can create a private variable that will call a float value, for example. And then now we create a public constructor here where we have number and someone passes in a float value. So the value would be, let's call it just a. And then what it does is it assigns the value a, like so. Sorry, value equals a, like so. And so that is our constructor. So while we are looking at this, there's something called a default constructor, and basically that's just a constructor that works in case we have not defined a constructor here. Then we have the default constructor. So if for example I remove this and we try to do number a, just like so, you see we are able to define this by default. So usually the default constructor would look something like this, number, where we do not have any parameters to pass. That's basically what the default constructor is. So in cases where we need, usually when we have this default constructor, you don't initialize your values. So we would do something like this. Let's say we initialize the value to 0, so that when we try to print, so allow me to create a function here, that a getter for our value. So of course to return our float, and then we call it get value, and it will return value. So here, if we try to print out a, like a dot get value, we can do it like so, and then when we run, you can see that it initializes our value to 0. So that's what the default constructor does. And in the case where we want now to have this, so we can now have our second definition where we can have something passed into this variable. So let's say 4, for example, and then when you run, now we have 4 printed out. So always, whenever you create your classes, always consider that you have a default constructor, and in case you need that definition to be there, always ensure it is present, because now in this case now, if you don't have this default constructor, sorry about that, if you don't have this default constructor, you'll see that you are unable to do this. you'll see that you'll raise this error where no default constructor exists for the class number. That means we are unable to just declare our instance of this class, our object, without giving it the specific parameters for our constructor, right? So it is always good to consider having this default constructor where it's needed. Now, next, after this, so we've already seen how the class works. So what happens when you have now operators? So operator overloading is basically so for example, if you're doing an addition, for example, of this number, then I'll just write, so I'm expecting that when you do an addition, we'll get back another number, right? And then we define operator, for example, and then we put the sign there. So now this is the default way of defining your operator overload. And then now in your brackets, you put in the number, another number that you'll get, of course, because you're adding this number that you already have to another number. So let's say x, for example. And what that will do is, as you're doing this, as you're executing, we want to we'll create, in this case, we'll create another number, call it results. And then what we'll do is give, so you want to assign the value of result as the same value as x. So what we'll do, since we can just construct it directly, x plus x dot get value plus now the value of our operator, which is still value, since you're already in the class. So and then we'll return results, like so. So now what this does is we are creating another number here, and we are constructing it with the value with the addition of the value of x, where you're doing x dot get value, and then the addition of the value that you already have in this float. So in this case, if we have another number here, let's say b, where its value is 5, for example, and then we say number c is equals to a plus b, you'll see that we don't get an error showing here. And then at the end of it, you can do c dot get value, and then when you run this, you can see that we get our value 9. So basically this is doing the addition for us. So this we have overloaded the operator plus, right? So we can do the same thing for minus. So of course, when you're doing a minus, you really need to check what is the order of the calling of these numbers, right? So we expect that the value will be the first value, because as you can see here, this a will be taken as the first value, and then b will be taken as the second. So when you take this, we need to do value minus x dot get value, right? And so we can do the same thing here, where we're taking 4 minus 5, so expecting -1. And so if I run this, you see we can get -1. So in this case, especially on the minus, if you had done it the opposite way, we would have gotten the value 1, which will not be accurate. So order also matters. So we can do the same with multiply, we can do the same with divide, but let me show you another trick. So you can see here, when you're doing stdc out, we see we have to do this c dot get value. So it's not only these operators, these numeric operators, that we can overload. We can also overload this operator right here, this two less than signs. So how do we do that? So here we have std string, and then we'll have our ampersand there. Remember, we usually do this by reference. So we have our operator, And there's something that I've still left out a little bit that I'm coming to explain in a bit. But here we're expecting this function to take an O stream, and we're expecting it to take as well now our number, which we'll call A, for example. Or let me call it X. Now, in this case, we need to put this as a friend function. And then we can do, so what we do is O stream. Oh, I did not give a name to this. Let me call this stream, or let me call it OS. So OS, then we use our signs there, and then we get x.get value, right? And then from here, now we return OS, which is our stream. So you can see we're passing in our stream, and we're passing it by reference so that we maintain it. We're also returning it by reference, right? And then we're getting our number here. So what this is supposed to do is we should be able to do this. We should be able to std cout c std endline. So basically, this cout is a part of this O stream. That's why we are passing it to this operator. So we are getting this O stream, and then now we are getting our number X, which allows us to do this since we are overloading this operator, right? So if I run this, you'll see that we are able to get our initial value, and we don't need to do the get value here again. So this is the beauty of classes, where you can have this operator overloading, right? It makes things a lot easier when you have this defined, and you don't need to keep on defining how you're going to do the printing, right? So adding friend to a function basically means that this function can be able to access the private members of the class, right? So in the situation where we have it here, so if I just show you, so this friend here basically means this function will be able to access this private values. So here we can also do x.value. Why? Because our friend function can access the private variables. Okay, so that's what the friend function means. That's in C++. Let's look at these situations in Python, right? So in Python, I think we can use the same scenario as we did in C++. So here we can have our class number, and then whenever we initialize it with a float value. So we can use this as, let's say, val, which is float, and then self.value will be given as val. Then so now we have our number class, right? So of course this class, if we declare our class here, for example, let's say x, which is a number type, is equals to number, and then we give our value a 5, for example. So when we do this, then when we print x.value and run, then we have our 5 here, right? So that's exactly how this will work. Now the next thing we can do is how do we overload an operator in this case? So for Python, it's not the same as it is in C++, where in C++ you use the actual operator, the value like the plus sign, for example. But in this case, you'd use the specific functions that allow you to overload. So it's a special function, and here we'll have, for example, def add, which is basically a function that will take that adds, and then we'll have now our second variable, which let's say we call it num, and then here we'll do self.value plus num dot dot value here. And of course, we have to return this, right? And so when we have, let's say, y, which is a number, as well as give it an actual variable, then we can have another variable which is also a number, which we'll call x plus y, right? And then here we'll print the value of z dot value, right? So we have a number which is 5 here, we have a number which is 4, and then we take x plus y, which you expect to get 9. So if I run this, all right, so here so of course it's complaining about this, where we are returning an integer. You see here we are returning an actual integer, we are not returning another number. So we also have to be careful about how we're doing this. So here instead we can be returning the actual number, right? So that it conforms to whatever we are expecting. So it creates a new number that we assign that way. So if I run this now, this should work. We have our 9. From here also, let's say if we need to do subtraction, we have sub, right, self num, and then we return a new number that subtracts, right? So when we do x minus y, we are doing 5 minus 4, which we're expecting to get as 1. And you can see that's the result that we get here. So that's basically how the operator overloading works. I've put a link on the description so you can see different types of operator overloading functions. There are a couple. Since we're using Python, we're not using the exact operator, then that means we need to know what these functions need to be called so that we can overload them, right? So I really hope you have come to learn something about operator overloading, about using classes. I hope you have understood how these work, and I hope this gives you an edge when it comes to how you're using your classes, giving you an extra advantage in terms of how you can simplify your code. You see, it's very easy when you can just do this plus this directly rather than having to do some extra manipulation on your main code, right? So I hope you've gotten to learn, and we'll see you next time.